Hello everyone. In this video we want to talk about properties of waves. We are going to start with lesson 2, which is talking about properties of waves. We want to know how to describe waves. What are the properties that we can use to describe waves? We want to identify parts of the wave first. Then we want to describe how the energy of a wave varies over time. Then we want to talk about the related wavelength, frequency and speed of a wave, explain how the properties of the medium affect the speed of mechanical wave. Then at the end we want to compare speed of sound in air at the standard pressure and temperature with the speed of sound in other material. Okay, let's start talk about the things that we use to describe the waves. Before we start, I want you to show you this one first. As you see here, you have two types of waves. One is going up and down, perpendicular. The other one parallel. Let's talk about the parts. We have talked about the upper part, the highest point here. We call it what? The crest, if you remember. And with this one here, the lowest one, which is we talk about the trough. Rate of action, which is when they are apart from each other, and compression, which is they are close to each other. Okay.
Now let's start learning about the properties of waves.
Now we want to talk about the properties of waves and what are the properties that we use to describe the wave. The first one that we use to describe the wave, which is called what? The amplitude. Let's look at it to understand what is the amplitude first.
Two wave properties are wavelength and amplitude. Wavelength and amplitude depend on the energy of the wave. To find out more, click a picture.
Let's understand what is the amplitude first.
A wave's amplitude is the maximum distance the wave vibrates from its rest position. The rest position is shown here with a yellow line. The height of a crest, or the depth of a trough, is the amplitude of a transverse wave.
Okay, again, to understand what is the amplitude, this line, this yellow line, is called the rest point. Okay, the highest point from the rest point, or this one, from the crest to the rest point, or the lowest point from the trough here to the rest point, it's called what? It's called the amplitude. So this is what the amplitude. As the amplitude increase, as you see here, as it has more amplitude, as you see here, which one to make one with highest or greater amplitude, if it's bigger like this, it means highest more amplitude, like, or greater amplitude. If it's go down, it's lower amplitude. Let's look at this one to understand this.
Waves with larger amplitudes have more energy. For example, sound waves with larger amplitudes have more energy and seem louder to us than sound waves with smaller amplitudes.
So again, look at this one. If we want to compare between image 1, this is 1, and image 2, the amplitude, as you know which is the distance between from the crest to the rest point, or from the trough to the rest point. And this is the second one. Which one? It has a greater amplitude, 1 or 2 for sure. 2. How this will affect? For example, sound wave with large amplitude have more energy and seem louder to us than the sound waves with a smaller amplitude. Okay, this example is important, and here you have to know by looking at this, and maybe I'll give you by numbers which one it has a greater amplitude or less amplitude. Okay, so this is about the first property we can use to describe the waves by its amplitude. Let's talk about the second thing, or the second property that we can use to describe wave, which is the wavelength. Let's talk about the wavelength.
Wavelength is the length of one complete wave cycle. One way to measure the wavelength of a transverse wave is to measure the distance between any two adjacent crests.
So here, if I want to talk about the wavelength, I want to measure the distance between two crests or two adjacent troughs. So this distance here between these two or these two is called what? Is called the wavelength. Okay? Let's look at the longitudinal wavelengths.
One way to measure the wavelength of a longitudinal wave is to measure the distance between any two adjacent compressions.
So for longitudinal it's different, it's not like that transverse. Transverse you can what? Measure the wavelength of a longitudinal wave is to measure what? The distance between any two adjacent compressions. This one is very important. Let's look at the wavelength and the energy.
The energy of an electromagnetic wave depends on the wavelength. Waves with shorter wavelengths transfer more energy than waves with longer wavelengths. Ultraviolet light rays have shorter wavelengths and more energy than visible light waves.
So here, if they are more close to each other, so it means what? Close to each other, which is what? Shorter wavelength. Shorter wavelength, it has like wavelength and more energy it has. Okay, so this one is very important. So till now we studied two properties that we can use to describe the wave, which is what? The amplitude and what? And the wave length. Let's look at the questions 5 and 6 on page 18. Here the first one mark the amplitude in two graphs above, and which wave has the greater amplitude. So if I want to look at the amplitude, let's draw first the rest line. So this is the rest line, for example. I'm going to do it here. I'm sorry if I'm going to use different color, which is better to show you what? To show you the rest point. For both, as you see here. So the distance here, you can do it by using your pencil, which is better. I'm going to make it like, I'll try to do it clear. This distance here is the amplitude, and this distance here is amplitude. This one is amplitude. Which one? It has higher, greater amplitudes. For this one, it has a greater amplitude, as you see. Okay, because the space is more, the distance from the rest point to the crest, or the rest point to and the trough. Let's look at the second one here for question 6. Mark the wavelength in the two graphs. This is the wavelength for this is the first one and the second one. And for example, for this one and this one, this is the wavelength. For this one, this is the wavelength here. Which one? It has a shorter wavelength. This one, it has shorter wavelength, and this one, it has this one. Number 1, it has shorter wavelength. Number 2, it has longer wavelength, as you see. So okay, so this is for question 5 and question 6. Until now we studied what? The two properties that we can use to describe the wave. Next time we will talk about the other property that we can use to describe the waves. If you have any question about this lesson, you can send me your questions. Thank you for listening.